I want to greet all of you in Jesus' name. I hope your week has been good. Welcome to our today's lesson. Today is 22nd July 2020. Your presenter, as usual, is Teacher Kirwa. Let me take this time to welcome all of you as you purpose to view through my Facebook page, Shadrach Protich Kirwa. And also later on it will be available in YouTube, Teacher Kirwa. So you visit YouTube, search Teacher Kirwa, subscribe, and like the videos there, and all shall be well for us. So I want to take this time also to welcome you to our today's lesson. We have always had Chemistry Wednesdays for the last 14 weeks, or the last 14 Wednesdays, as we stay home, as we learn from home. So we have done this is our lesson 4 on organic chemistry. We started the first lesson by doing an introduction to organic chemistry. We looked at alkenes, and last week we winded up looking at alkenes. We did isomerism, preparation of alkenes, physical and chemical properties, and lastly we looked at the uses of alkenes. So today I want us to look at alkenes. This is the second part of that discussion. The second part, the lesson is lesson 4. So I told you when we began looking at this topic that we have 3 hydrocarbons that we are going to discuss under organic chemistry 1. One is alkenes, the one that we already have done a coverage on. We also have alkenes that we are doing now, and later on we will wind up by looking at alkynes. So feel free, any questions you have, drop it in the comment box, and we shall be good to go. So welcome now. So alkenes. All right. So when we looked at in our introductory part, we said these are hydrocarbons, and I also told you that these 3 types of hydrocarbons are grouped depending on the number of bonds between the carbon atoms. Alkenes have single bonds. Alkenes, this one, have double bonds, and alkynes have triple bonds. So maybe we can start by saying they are unsaturated hydrocarbons having at least one double bond between 2 carbon atoms. So alkynes are unsaturated hydrocarbons, and they have at least one double bond. At least meaning they could be 3, they can even be 4, but at least there is one double bond between 2 carbon atoms. That is in bracket So this is how we show hydrocarbon alkenes. So in between these carbon atoms we have a double bond. So that is why we are saying it is unsaturated. So we have saturated hydrocarbons, that is alkenes. Alkenes are saturated, as we saw, because it is composed of single bonds along the carbon chain. But this one have a double bond between 2 carbon atoms. So this is what is said to be alkenes. Now, so the double bond the double bond serve as a functional group. So this double bond here is referred to as a functional group. Maybe we can define a functional group. So a functional group is an atom or group of atoms that give a compound that gives a compound characteristic chemical property. So this is a group of atom. It is an atom or a group of atoms that give a compound characteristic chemical properties. That is what is referred to as a functional group. Now, this means when we say the double bond is the functional group in alkenes, now that translates to it is along this double bond where chemical reactions occur. So for any chemical reaction to occur, then it occurs across the double bond. That is the functional group. When we were looking at alkenes, we said alkenes do not have a functional group. And because they do not have a functional group, they have limited chemical properties. That is why alkenes, we said they only have one chemical property, that is substitution reaction. And even as such, for substitution reaction to take place in alkenes, as we saw, there has to be UV light or sunlight. So for this, it does not require UV light. We shall look at it because of the presence of this functional group. Okay. So that is the introductory part of the alkenes. Let's look at nomenclature. Nomenclature of alkenes or naming. Naming of alkenes. Now maybe let me just mention this. When naming organic compounds, there are a set of rules that are followed. This set of rules are given by an international unit that is called IUPAC. IUPAC. IUPAC in full means, this is International Unit of Pure and Applied Chemistry. I'm just mentioning that you can just grasp. Now, so the naming that we do in chemistry, in organic chemistry, follows International Unit of Pure and Applied Chemistry rules. This is a unit which give rules on how organic compounds are named. You remember in biology, we have something called binomial nomenclature, a set of rules of double naming. So that is for biology. So for chemistry, we have IUPAC. So when we are naming these alkenes, alkenes, alkanols, all those organic compounds, then we follow the IUPAC. That's just by the way. Now, we mentioned in our last topic, subtopic, that, there is one point I forgot. Let me write it here. The general formula for alkenes is CnH2n. The general formula is CnH2n. For alkenes, we said the general formula was CnH2n plus 2. Okay? This was for alkenes, CnH2n plus 2. Now for alkenes, it is CnH2n, where we said n is the number of carbon atoms, where n is equal to number of carbon atoms, starting from 1 and above. So if n is equal to 1, then we know. Now, let us revisit something that we have said here. In our introductory part, we have said they have at least one double bond. Okay? They have at least one double bond between carbon atoms. Now, that means our first, you remember when we were naming organic compounds, anytime we name organic compounds, where we have n is equal to 1, the prefix is men. Okay? Where we have n is equal to 2, the prefix is n. This is just a preview. Where we have n is equal to 3, the prefix is prop, etc. Now, if we are saying there has to be a double bond between two carbon atoms, then that suggests that we do not have, in alkenes, we do not have where n is equal to 1. Alright? So, when we are naming n is equal to 1, we don't have this. Alright? Because for alkenes, we had the first member was CH4. Okay? This was the first member. Now here, the first member of alkene, the first member of alkene series is where n is equal to 2. That is ethene. Okay? So the first member is where n is equal to 2. So if n is equal to 2, so what is the formula? We have said that the formula is CnH2n. So that means this is C2H. This is 2. 2 times 2 is 4. So C2H4. Okay? So this is the molecular formula. The structural formula, we have said we have carbon, double bond. Okay? And then you remember we said carbon is tetravalent. So because carbon is tetravalent, we need to have 4 covalent bonds around every carbon atom. So this will be 1, 2, so 3, 4, 1, 2, 3, 4. So that is the structural formula of the first alkene member, that is ethene. So where we have a double bond and then 2 hydrogens. So C2H4. Second member, member number 2 is where n is equal to 3. Okay? Where n is equal to 3, this is C3. So we are following the general formula CnH2n. So C3, H2n is 3 times 2 is 6. So H6. Again, we have 3 carbon atoms. We need to have a double bond between the first and the second carbon atoms. And then we have third carbon atom. Now for hydrogens, you fill the remaining tetravalency using hydrogen. So these are 1, 2, so 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. You will realize that we have 1, 2, 3, 4, 5, 6. We have 6 hydrogens and 3 carbon atoms. So this one is called propene. Okay, so we are doing eth prop, and then you only add the suffix is ene for all of them. So the next one is n is equal to 4, that is C4H, 4 times 2 is 8. Then you have double bond, 1, 2, 3, 4. So hydrogen here. 1, 2, 3, 4. Okay, etc. So this is called butene. But means 4. Okay, but means 4. So when you say but, 1, 2, 3, 4, and then in is shown by the double bond. Alright? Now you can go on with the rest, where n is equal to 5, n is equal to 6. So you can find the rest of the formulas using the general formula and the number of carbon atoms, where n is equal to 5, pentene, hexene, etc. So that is how naming is done. It is almost similar to alkenes. The only difference is the suffix. The suffix. So next is isobarism in alkenes. Isobarism in alkenes. Now isobarism, as we said there in our last lesson, we defined isobarism as the existence of compounds with the same molecular formula but different structural formulas. That is isomerism. So isomerism is existence of compounds with the same molecular formula but different structural formulae. So the same molecular formula but different structural formula. Now we can say for alkenes exhibit two types of isomerism. Alkenes exhibit two types of isomerism, that is branching isomerism and positional isomerism. Okay, branching isomerism and positional isomerism. Branching isomerism is due to the presence of a branch. You remember when we were doing alkenes, we said there are two types of branches. We have alkyl branch or halogen branch and either. So we have alkyl and halogen, where we saw compounds like 2-methylbutane, 3-bromobutane, etc. Now for isomerism in alkenes, it exhibits two types of isomerism. We have branching isomerism due to the presence of the branch, and then positional isomerism is due to the presence of the double bond or the functional group. Okay, for example, look at this compound. Now look at this. Oh, sorry. Let me draw it afresh. So 1, 2, 3, 4. Then that is here. This is carbon number 1, 2, 3, 4. This is carbon number 1, 2, 3, 4. Okay. So you see the double bond here is between carbon number 1 and 2. So because we have 1, 2, 3, 4 carbon atoms, then it is a bute. Okay, it is a bute because for even this one is bute. Now the difference is the positions of the double bond. So the positions here we have carbon number 1 and 2. So because they are between two carbon atoms, then the double bond is assigned the lowest number. So because it is between 1 and 2, then we will say it is at carbon number 2. I mean carbon number 1 because 1 is the lowest. So this one becomes but 1 in. Alright? But 1 in. You remember we said the number is separated by the name using the hyphen. So this is but 1 in to say we have 4 carbon atoms but, and then we have a position at carbon number 1 we have a double bond. This one is but 2 in to say we have 4 carbon atoms and it is a double bond, but the double bond is at carbon number 2. As we have said, it is between carbon number 2 and 3. But now we assign it the lowest number. So it becomes but 2 in. So let's look at this other one. Now this is now what we call positional isomerism. So these are positional isomers of butene. Positional isomers. Positional isomerism, where we have a difference in the position of the double bond. Now if we introduce a branch, let us introduce it here and here. Okay, so let me take, you remember what we did? We can take this and put it at carbon number 2 here, so that you have double bond. Then we have that. We bring this here. Okay, CH3 here. One, two, three, 4. This one is full. The tetravalency here is okay. 1, 2, 3, 4. So you don't have hydrogen. Then here, here. You realize that this one is still 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. 1, 1, 1. Okay, we don't have one here. Sorry for that. For this carbon to be stable, we have 1, 2, 3, 4. So hydrogens are 1, 2, 3, 4, 5, 6, 7, 8. It is still C4H8. Now let us look at the name. So the parent, you remember we had the parent and the branch. Okay? Then the branch. And we have the full name here. So we are saying the parent name, you remember we said the parent name is the longest continuous carbon chain. Now in alkenes, the parent name is the longest continuous chain containing the double bond. Okay? So this one, the longest continuous chain here is 1, 2, 3. You cannot take 1, 2, 3 here. Okay? You cannot say 1, 2, 3 because if you take 1, 2, 3, the double bond is off the chain. Are we together? The double bond is off the chain. So you take the chain where it consists the double bond. So we'll have 1, 2, 3. So the parent name is a prop. So prop, and the double bond is at carbon number 1. So you call it prop 1 in. Okay, prop 1 in to say 3 at carbon number 1 we have a double bond. The branch at carbon number 2 we have a CH3. You remember CH3 we called it methyl. So at carbon number 2 you have a methyl branch. Now give it the whole name So the two names, you begin with the branch, you end with the parent name. So you have the whole name becomes 2-methyl prop 1-ene. Okay? 2-methyl prop 1-ene. Prop 1-ene is the parent name. And then 2-methyl means there is a methyl branch at carbon number 2. Okay? Let us have this other one. Okay. Let me have this. I don't have this. Sorry. I'm gonna assume that. One, two, three, four, five. 1, 2. This one is 1, 2, 3, 4. This is 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So this is 1, 2, 3, 4, 5. It is C5, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. H10. You see, it follows CN H2N. Okay, as we say, the general formula for alkenes. Now let us name this compound. When we are naming this compound, you begin numbering. So let's say number from the end closer to the double bond. You begin numbering from the end that is closer to the functional group. So that here we have two types of numbering. You can say 1, 2, 3, 4, 5. From the other side, 1, 2, 3, 4, 5. Now, let us look at case number 1. When you begin from 1, 2, 3, 4, 5, the double bond is between carbon number 3 and 4. So the double bond is at carbon number 3 and 4. Okay? If you begin from the other side, it will be 1, 2, 3, 4, 5. The double bond is between carbon number 2 and 3. So that means we should take this, the second case takes the precedence. We begin numbering from here. So this one will be 1, 1, 2, 3, 4, 5. Okay? So that you have, so the name becomes, because you have 1, 2, 3, 4, 5, the chain contains 5 carbon atoms, then it is pent. And then you have the double bond at carbon, we have said between carbon 2 and 3, and we have said you assign the lowest number. So it is at carbon number 2. So pent 2 in. Okay? Pent 2 in. Let me introduce a branch there. 1, 2, 3, 4, 5. We had a double bond there. Let me introduce a branch here. A bromine branch. Then we have hydrogen, hydrogen. This is 1, 2, 3, 4. This is 1, 2, 3, 4. It's okay. 1, 2, 3, 4. 1, 2, 3, 4. Let us name this compound. When you are naming, you remember our rules. Number 1, you should have the parent and the branch. Number 2, you number the longest continuous chain containing the double bond from the end that is closer to the double bond. So we have, this will be 1, 2, 3, 4, 5. Okay? So at carbon number 2 we have a double bond. At carbon number 3 we have a branch. So the parent name is pent 2 in. The parent is pent 2 in. Pent because of 5 carbon atoms, 2 because of the double bond at carbon number 2. And then you have the branch. The branch, you have at carbon number 3, you have a bromine branch. So you say 3 bromo. Okay? We say the halogens, we say bromo, chloro, iodo, etc. Fluoro. So the whole name now becomes 3 bromo pent 2 in. So 3 bromo pent 2 in. Okay? 3 bromo pent 2 in. Lastly, let us reverse. Let us write any name and then we give it. Okay, let me just write any name and then we draw. We go reverse. 2, 3. Sorry, 2, 3 methyl X3 in. I've just written any name that comes to mind, okay? 2, 3 dimethyl X3 in. Alright, let us draw this compound. Now, when we are drawing, we begin with the parent. So split this into 2. Find the parent and then the branch. So the parent name is hex3 in. Hex means 6. Okay? And then 3 in means at carbon number 3. So hex, draw 6 first. So we have hex. So that is 1, 2, 3, 4, 5, 6. Okay? So we have 6 carbon atoms for hex. Now, at carbon number 3, you have a double bond. So, 1, 2, 3 here. You have a double bond there. Okay? At carbon number 2 and 3, you have 2 methyls. Are we together? Dimethyl means you have 2 methyls. So, at carbon number 2 and 3, so carbon number 2 and 3. So, 2, you have a methyl. Carbon number 3, you also have a methyl. Methyl is a CH3. Anything else that we need from here? So at carbon number 2 and 3, you have 2 methyls. The name is X3 in. Then you fill the rest of the bonds that remain using hydrogen. So for this, we have 1, 2, 3, 4. This is 1, 2, 3, 4. This one here is 1, 2, 3, 4 is okay. This one is 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So that is how you draw. So when you are drawing, you begin with the parent name and then the branch, and then you fill the bonds using hydrogen. Okay, so that is nomenclature and isomerism. The most important thing to remember is that alkenes exhibit two types of isomerism: branching and positional. So I want us to do preparation of alkenes in the lab, and then we can start from there in our next lesson. So lab preparation or preparation of alkenes. laboratory preparation of alkenes. Okay, so alkenes are prepared by dehydration of alkanols. They are prepared by dehydration of alkanols. Alkanols is another group of organic compounds. It is under organic chemistry 2. We shall look at it later on. So alkenes are prepared by dehydration of alkanols, where dehydration is the removal of water or elements of water. Maybe I can just define dehydration is the removal of water or elements of water from a compound. Removal of water or elements of water from a compound. So for example, we can have, if we have, let us consider this. So we are using ethene. We will be using ethene in our discussions to represent all the other alkenes. So preparation of ethene. H5OH. This is ethanol. Okay, ethanol, and then we have dehydration by Kong sulfuric 6 acid. Kong sulfuric 6 acid at temperatures of between 160 to 180. Okay, so Kong sulfuric 6 acid temperatures of 160 to 180 degrees centigrade. You have C2H4. This is ethene, okay, and water, gas. So that is what we have. So this is dehydration of ethanol. So ethanol undergoes dehydration to give ethene and water. Propanol undergoes dehydration to give propene. So to get propene, propanol. To get butene, butanol, and so on. What we need to note here is Kong sulfuric 6 acid acts as a dehydrating agent. Kong is concentrated. You may not be knowing this. Concentrated sulfuric 6 acid acts as a dehydrating agent. Under sulfur and its compounds, we learn Kong sulfuric 6 acid under sulfur and its compounds. So when we learn about that, we say Kong sulfuric 6 acid acts as a dehydrating agent. That is, it removes water or elements of water from substances. Even in so when we are looking at dehydrating properties of sulfuric 6 acid under sulfur and its compounds, it also dehydrates sugar, okay, to remain with carbon. So it dehydrates, it removes elements of water from sugar or glucose. So that is, so Kong sulfuric 6 acid acts as a dehydrating agent. The other very important, so the reagent is Kong sulfuric 6 acid. The condition is temperatures of between 160 to 180. Just to mention, if the temperatures were not 160, we have below 160, that is 160 downwards. Say between 160, 140 to 160. When we have this, the product will not be ethene. The product will be another chemical compound that is called diethyl ether. We shall look at we shall mention this when we do organic chemistry too. But when you have these temperatures of between, so when we say between 160 to 180, it can be 170, can be 175, any figure between these. Otherwise, it should not be between 160. The product will not be alkene. It will be diethyl ether. So that is how alkenes are prepared in the lab by dehydration of alkanols. For the also, instead of using this Kong sulfuric 6 acid, aluminium oxide can also be used. So it is either Kong sulfuric 6 acid or aluminium oxide. Aluminium oxide can be used instead of Kong sulfuric 6 acid. It does the same thing. In this case, aluminium oxide can also, maybe I can write that as a sentence. Aluminium oxide can be used in place of Kong sulfuric 6 acid, where it will act both as a catalyst and as a dehydrating agent. Where it will act both as a dehydrating agent and as a catalyst. So that is what can also be used in place of Kong sulfuric 6 acid. So that is a preparation of alkenes. All the other alkenes follows the same method of preparation. You will also remember that alkenes can also be obtained by cracking of long chain alkenes. We said when long chain alkenes, you review the last topic, long chain alkenes are broken down to give a shorter chain alkene, an alkene, and a nitrogen gas. So that is just a mention to show how alkenes can also be prepared. I wish to wind our lesson there for today, so that in our next time we begin by looking at the physical and chemical properties of alkenes, and then we wind up there on alkynes. You realize most of the things we'll do for alkenes also apply for alkynes. So folks, that is the end of our lesson today. I wish to thank you for coming through. Thank you for tuning in. We have had a number of students watching. Let me see. Maureen Murray, that is my wife. Thank you very much. We have Mercy Chaps, we have Ariana, and yes, so I want to thank you for coming through. Thank you for tuning in. I want to wish you God's blessings. You can also visit my YouTube page later on for a better version of this and a more improved one. So until next time, stay safe, sanitize, may God bless you. Bye bye.